Okay. Okay, so polynomials are just expressions with one or more terms. So they're just expressions with one or more terms. Okay, and think of it this way. We are all human in here, yes? Okay. However, some of us are girls and some of us are boys, yes? So we could get more specific than human, right? And we could get even more specific than that if we wanted, right? But that's how it is when it comes to terms. So we can call every expression a polynomial, but there are more specific. So if there's only one term, we can also call that a monomial. So that's more specific. We can call something with two terms a binomial, three terms trinomial, and I don't know why I did an extra row, but anything with four or more, the only thing we can really say is a polynomial. I got too excited with rows. Okay, but again, these first three can still be called a polynomial. Okay, so they can be called both, but more specifically, they can be called the more specific names which are inside the box. Yes? Now, what are terms? How do we know terms? How do we identify terms? They usually have letters, but not always. Letters are also known as what? Starts with a V. Not value. Variables. Okay, and terms have variables, but they don't have to. So terms, the way we identify them is they're separated by plus or minus. Which I'm going to show you all an example here in just a second. But I'm going to go over all the things first and kind of show you it all together. So separated by plus or minus. So if we have 3x plus 2, that's two terms. Yes? 3x, how many terms is that? 1. There was no plus or minus. Okay? So degree, this is going to sound really confusing until I show you what it means. And once I show it to you, you'll understand what I'm saying. Yes? So a degree of a polynomial is the sum. What's sum? Addition. Sum of the exponents. What are exponents? They're the little numbers, right? The little numbers up top. Yep. Of its variables. What are variables? What are variables? Not quite. What? They're letters. Those are examples, yes. So it's any letters per term. And the term with the highest degree, I don't know what I was about to write after the word highest, is the degree of the polynomial. So let me show you what I mean by that. So if we have an example like 3x squared y minus 4x squared y cubed. Well, first off, how many terms is that? What did we say terms were separated by? Plus and minus, so we have a minus sign here, so how many terms? 2, which makes this a binomial. What if I added 1? How many terms is it now? 3. It's a trinomial. Everybody okay with that? Okay, so that's what I mean by these. Now, what else could we call it instead of a trinomial? A polynomial. You're exactly right. Okay, now we want to figure out what degree it is. Okay, so when it comes to degrees, now if we look here, this is where it makes more sense, and this is how we're normally going to see it. If you look at this problem, this is a degree of 2, this is a degree of 1, and this is a degree of 0 because there are no letters with exponents. There's no letters at all, right? This has a letter. It doesn't have an exponent, but if you put an exponent, what could you put there in the middle? A 1, right? Okay, so this is 2, 1, 0. This works its way. It's in order, correct? Don't we want it highest degree to lowest degree and it's in proper order? Okay, so that's why it's important to know degree. But here, when you have multiple letters, that's where this statement comes in. So you add the exponents of the variables only, not the number, not the coefficient, just the variable. So here, what's my exponent?
2.
And what's my exponent for the y?
1.
So what's 2 plus 1? So this term has a degree of 3. What's my exponent here?
2.
Plus?
3.
So what's my degree here?
5.
Now, do I have any variables?
No.
So what's my degree?
1.
0. Because it's only the variables exponents. And if there are no variables, there's 0. Okay? So is this in proper order? No. Remember, in order we go highest degree to lowest degree. So this is a 5th degree trinomial. Now, we're not going to rewrite it because I'm not that worried about it. This was just an example so I could show you what I meant by that. Does that make sense? Okay. So now we're going to do some problems. And like I said, I'm not quizzing you on that, but I need you to understand how to put a trinomial or a binomial in order. Cool? Awesome. Okay, look at number 1. So this is similar to what we did last week and the week before, but what's different? What am I distributing on the first one? A letter, M, not a number. Before we were just distributing numbers. They had letters, but now we're distributing a letter to a letter. What happens when you multiply a letter to a letter? It's going to become squared because it's one and another one. Okay, do y'all remember what you do with your exponents? Like on this one, what would I do with my exponents? So how many's here? 3, and how many's here? 1. So how many would that be when I multiply? You're exactly right. What did you just do? Add. You add your exponents when you multiply. So when you multiply, you add exponents. So knowing that, m times 5m becomes what? Yep, 5m squared. M times negative 2?
Negative 2.
Perfect. 9 times 5? Positive 45. And 9 times negative m. Perfect. Do I have any like terms? Yes, what are they?
Negative 2 and
The negative 2 and the negative 9. Now, before I combine those, what needs to go first? Which exponent? Remember, we go highest degree first. So the 5m squared has to go first because that has a degree of 2. These have a degree of 1, and this has a degree of 0. So, because if you're like me, I don't want to write this a million times. Like, I don't want to write it out of order and then have to rewrite it in order if I can avoid that. Does that make sense? So let's think about that beforehand so we don't have to write it a million times. So 5m squared goes first. Now, that's a degree of 2. Do I have stuff with a degree of 1? Well, yeah, my two like terms have a degree of 1. What's negative 2 minus 9? Negative 11, so I have negative 11m. And then I have this 45 that had no like term, and it's a degree of 0. So now I have a degree of 2, degree of 1, degree of 0. It's in order. There's no like terms. That's my answer. Any questions with that? Okay, so let's look at this one. Let's distribute. So this one's a little more because it's got an exponent. What's negative z cubed times 9? Negative 9 z cubed. Yeah, z to the 3rd power. Now, if you need to break them up when they have a bunch of stuff, you can. Negative times positive is negative. There's no number here, so we're just going to bring the 9 down. Or you can think of it as a 1. 1 times 9 is 9. Z cubed, there was no z, so just bring down the z cubed. Okay? Now, negative z cubed times negative z. Well, negative times a negative is a? And what's z cubed times z? What do we do to our exponents? Add them. And if it doesn't have one, what can I put there? 1. So what's 3 plus 1? Perfect. So there's my first set of parentheses gone. So now we need to get rid of our second set of parentheses by distributing again. So what's 4z, English, 4z times 2, positive 8z, Plus what? Not 7, don't add.
Oh. So I'm just like, that's
12z what? Squared. Perfect. Now, do I have any like terms? This is cubed. There's no more cubes. Fourth power, no more fourth power. First power, no more first power, and squared. So there's no like terms. I can't simplify it, but is it proper? No. So when I rewrite it, what needs to go first? Yeah, the highest degree. So what is my highest degree? So z to the fourth. Then what?
Then negative
Minus 9z cubed. I like to cross things off as I go. Then what?
12z cubed.
Positive 12z squared. And last but not least, my plus 8z. So not too bad. We just had to reorganize it. Everybody okay with that? Pretty simple. So the front should be a review, kind of what we just did. The only difference was we're actually multiplying letters. Yes? Now the next two are straight up review. Straight up. I don't know. Why are you messing with me? Okay, look at this one. Do we need this first set of parentheses? No. Do we need the second set of parentheses? No. Why not? What's in the middle? Plus sign. And does that change anything? No. A positive stays positive. Positive and a negative stays negative. So can we ignore all the parentheses and just combine like terms?
Yeah.
Yeah, there's a plus in the middle, so I know I'm just adding and subtracting my like terms. So what are my like terms? Well, here I have a 15x squared. Do I have another x squared? Yeah, I have a negative x squared. Here I have x. Here I have an x. Here I have a constant, and then I have a cube. So what needs to go first? What's my highest degree?
2x to the third.
To the third power, my cube. So my 2x cubed, did it have a like term? No, so I'm just going to bring it down. 2x cubed. And like I said, I'm weird and I like to cross things out. That's how my brain works. Okay, now what? Squared. So what's 15x squared minus x squared? Positive 14 x squared. Because it's like saying 15 minus 1. Then I have my negative 3x plus 6x. What does that give me?
3x.
And then I have 11 plus 1. 12. It's in order. It's simplified. There's my answer. Now, do I do number 4 the exact same way? Ignore the parentheses, combine like terms?
No.
No, why not? What changes it?
The
What's the difference?
negative 4 becomes
The subtraction in the middle. Okay, now can I ignore the first set of parentheses?
Yeah.
Yes. But I have to distribute that second set of parentheses because I'm taking away this whole thing. So 2 negatives makes a
Positive.
negative, and a positive makes a negative. Negative and a positive makes a negative. Now can I just add and subtract my like terms? Yes. So I have a squared, and I have an x and a constant. So what do I need to combine first? The x squared. So what's 3x squared minus x squared? Then what? So what's negative 5x minus x? Do y'all notice that I keep that sign in front with it? That's super important. And then 4, is there a like term with 4? No, so just bring it down. Any questions with those? Pretty simple, pretty review. Okay, we're not going to do number 5 because number 5 is literally number 3 and 4 put together. And number 6 is a lot like what we've already done that we're already going to practice multiplying, so we're just going to flip to the back. Trying to make the long notes a little shorter for a Friday. You know. Okay, so the thing I want to remind y'all is when you multiply, you add exponents. And the reason being, some people really get thrown off with this, is if I have x squared times, or even with parentheses, x cubed, well, isn't that the same as saying x times x? And what's another way of writing multiplication other than parentheses? Can't I just use a dot again?
Yeah.
So that's like saying times 1, 2, 3. Well, how many x's is that? 5. That's why you add them, because exponents just tell you how many times you're multiplying something. So if you multiply it 2 times and then you multiply it 3 more times, that's a total of 5 times. Your exponents are just the total addition of how many times you multiplied it. Okay? That's why you're adding your exponents. Okay? So knowing that, 1 is a little messy. And when you look at it as a whole, it's a lot. But when you break it apart, like I'm going to show you, it's really not that bad. Okay, so knowing that, we're going to distribute. There's only 2 terms in that second set of parentheses. So I'm going to start with just the numbers. What's negative 4 times 5? Huh? Negative 20. No, you're fine. And then we have c squared times c. Add the exponents. How many c's is that? 2 plus, so that's, then we have cubed and squared, so that's d what? So there's my first term. See what I mean is when you break it up, it's really not that bad. Now when you look at the whole thing together, it's kind of a lot. Okay, now do the next piece. What's negative 4 times 3? Okay, 2 times 2, are we sorry, 2 plus 2? And then 3 plus how many?
4.
It's going to be 4 because there's 1 when there's nothing. Now, is this in order?
No.
It's kind of a trick question. It is. Could I flip it and it still be in order? Yes. What's the degree of this term? And what's the degree of this term? 8. It's kind of a trick question, you see what I mean? So it is in order, but you could flip it and it would still be in order. But because 5, remember, you add your exponents for each term. So 5 plus 3 is 8. 4 plus 4 is 8. So the order's fine. However, if you flipped it thinking it was out of order, would you still be right? Yes. But be very careful with that. Now, number 2 is how we're going to see it more so than number 1. This is more realistic with what we're going to see. Okay? So knowing that, what do? We distribute. Yeah. What's negative 3x squared times 5x squared? Y'all are exactly right. What's negative 3x squared times 6x?
3.
X to the 3rd power. And negative 3x squared times negative 1. Remember, anything times 1 is itself, and 2 negatives makes a positive. Is it in order? Are there any like terms?
Yes.
No, so we're done. Pretty simple. We like that one. Okay, we're going to kind of do the rest out of order. I know it's weird, but it is what it is. We're going to do 3, 5, and 6 before we look at the other ones, okay? Because 3, 5, and 6 are similar, and I don't want to throw anybody off. So look at number 3. We've all done these kind of problems.
Yep.
Who remembers what we call it? There's 2 different things.
Wait, inside.
What do we call this? Okay, and aren't we just going to do that twice here? So one of the things that some teachers call it is double distribution. That's what I call it. And what you were saying,
Inside.
that's one of the letters.
Outside.
Okay, you're going backwards, but it works.
That,
So it's foil. First, outer, inner, last.
oh yeah.
Okay? So you can also call it foil. I don't ever call it that because I feel like people got so thrown off with like which ones are the first, which ones were the outside. Like it, anyways. I call it double distribution. That's the way my brain works. That's what works for me. If you prefer to think of foil, that's totally fine. Everybody's different, okay? So the reason I think of foil, dang it. Y'all, it's Friday. It's my last class. Okay. Is the reason I call it double distribution is because you're literally just distributing twice. Now, there's nothing in the middle of the parentheses. I didn't know, I just covered it. But there's nothing in the middle of the parentheses, meaning we're multiplying. There's no addition or subtraction, right? That's why we're distributing. And I have 2 terms times 2 terms, a binomial times a binomial. So I have to take both of those terms times both of those terms. So the reason I call it double distribution is because I'm going to cover up that second term and I'm going to distribute that first term just like I've been doing. What's 3x times 2x? 6x squared. And what's 3x times negative 5? So look, that's our first distribution, and now I'm going to cover up that other one, and I'm going to do it again. That's why I call it double distribute, because I'm just doing it twice. What's 2 times 2x? Positive 4x. And what's 2 times negative 5? Now, 95% of the time, those middle 2 terms are going to be like terms. Are they like terms? Yes. And the first and last will not have like terms, do they? No. So bring it in. It's already in order. So 6x squared. What's negative 15x plus 4x? And then bring down my minus 10. There is your answer. Now do you understand why I call it double distribution? Double distribute. Because you just distribute twice. Okay? So I want y'all to try these two while I take attendance. Before I let you try this one, what does squared mean? Twice. Does it mean give the squared to both? Or does it mean rewrite it twice? Rewrite it twice. Do not give the squared to both and try that because it's wrong. Okay? And you'll see why in a minute. So you're going to try to double distribute both of these and then we're going to talk about them. If I can find my mouse. If my computer will work. My internet's so slow it still hasn't opened. Maybe I won't take attendance. Okay, I'll try again in a minute. There it goes. Everybody's here. Okay, so on the first one, you should have gotten 4x squared minus 2xy, because those are not alike, so they just kind of line up alphabetically, minus 2xy again, because again, you want them in alphabetical order, and then 2 negatives makes a positive, so plus y squared. Any questions with that?
The y would go before the x and y.
Right here?
Either y squared wouldn't go before the x and y.
No, because they're all still degree of 2, degree of 2, degree of 2, degree of 2, degree of 2. So it's not out of order. And I wouldn't move orders until you're done multiplying and simplifying anyway. So now these two are like terms. So we have 4x squared minus what? 4xy plus y squared. They're both negative. If one of them was positive, they would have canceled, and they wouldn't be there at all, but they're both negative, so I take 2 more, I took 4. Now, we call this perfect square trinomials. Why do you think we call it that? Well, didn't we square a binomial to get it? Yeah. And if you notice, the first term and the last term are perfect squares. Any questions with that one? Okay, these are the ones that we like when we're factoring. So when we're going backwards, you're going to like these ones. Okay, I promise. So we should have gotten 4x squared plus 2x minus 2x minus 1. Everybody okay with that? Any questions about that? Well, again, are my middle two terms like terms? But what do they, yeah, you're exactly right. They cancel out. That gives you 0. So you're left with 4x squared minus 1. There's your answer. So we call this the difference. What's in the middle? Subtraction. Isn't that another word for difference? Of two squares. Or you could just hear difference of squares. They're the same thing. Okay, the reason we say of two squares is 4x squared. Isn't that a perfect square? Yeah, 2x times 2x, isn't that 4x squared? And then 1 times 1, isn't that 1? And it's subtracting in the middle. So anytime you have the binomials that match, but one's plus, one's minus, it's the difference of two squares. Okay, so we're not going to do number 4, but we're going to talk about it, and then we're going to do number 7, and then y'all will have a little bit of time for practice, and then I'm going to let y'all pack up a little early for Friday. So, example 4, what's different from these 3 to this one? Well, how many terms does this one have? So what do we call that? Binomial. How many does this one have? What do we call that? A trinomial. So these were binomials times binomials. What's this one? Binomial times trinomial. Y'all, all that means is that we're going to multiply an extra arrow each time. So instead of having 2 arrows, guess what we're going to have? 3 arrows, and multiply 6 times. You're exactly right. So we're not going to do this one because it's the exact same thing. You just multiply an extra time. So it would be like t times this, times this, times this, and then 2 times this, times this, times this. Pretty simple, yes? Nothing crazy. Now, look at example 7. What's different about that one? It's a trinomial times a trinomial. So this one is a little more gross. So I'm going to do this one with you because I want to show you an organizational tactic to make this one easier after you multiply. Okay? So it's not hard. It's just a lot, right? Okay, so we're going to get started. 2x squared times x squared. What's that going to give me? 2x to the 4th. 2 plus 2 is 4. 2x squared times 5x. Well, 2 times 5 is 10, and x squared times x is x cubed. You weren't wrong. 2x squared times negative 2. Negative 4 x squared. So there's our first one. We're done. Okay, so now we're going to do that middle term, that negative 3x. So what's negative 3x times x squared? Don't write anything yet. Is negative 3x cubed, right? So we're going to line it up with the cubed. So negative 3 times 1 is negative 3, and x times x squared is x cubed. Okay, negative 3x times 5x is negative 15x squared. Do you see how they line up? And then negative 3x times negative 2. What kind of 6? Plus 6x. Or no x. Yes, x. Just kidding. Losing my mind. Okay, one more. Last one. I told y'all it was a lot. But you'll understand why I'm telling y'all to line them up here in a second. Okay, last one. 4 times x squared. So we're going to line it up with the x squared. So positive 4x squared. 4 times 5x is 20x. Positive 20x. And 4 times negative 2. Negative 8. Now is it going to be simpler to combine my like terms? Because they were both in order and they had the same type of terms, they just scooted over once every time. And now my like terms line up and it makes my life way easier. So bring down my 2x to the 4th. And I'm just going to read it down. So what's 10x cubed minus 3x cubed? Positive or negative? Positive. I just need to know so I know if I'm putting a plus or a minus. So it's a positive 10, so that's bigger. That's why it's positive. Then I have negative 4x squared minus 15x squared plus 4x squared. How do we know that really quick? The 4's cancel. Or could you have just typed negative 4 minus 15 plus 4 in your calculator?
Yeah.
100%. Then what? Yeah, and then what? There you go. So it's gross and it was long, but it was organized, so it wasn't as bad combining our like terms. If that was in a big long line, it would have been way more annoying trying to find your like terms. Does that make sense? Okay. So there's 14 practice problems. Most of them are on the front.